Hello everyone, I am Kishan Omkar from Team Chilli and we have worked on FinSpark problem statement number 2. Let me show you the prototype we have built so far. So here is our prototype AI fraud intelligence dashboard, and for this prototype we have trained different models. Here you can see a 3D graph view in which I will show you how will be the graph be connected later. And we have four models for the detection of fraud on in online banking systems. So first is network intrusion detection. So I have added two buttons. For first is for normal data, which is sent or which comes when there is no fraud or any anomaly happening on the internet. And second data I have prepared for suspicious data that will come when someone will try to hack bank systems or send some data packet that is not accurate with the bank systems. So the mainly difference is that they use the services like private flag s0 and many more. So like if there is no fraud, let first run the data for no fraud, and as soon as we run prediction, the ML model will check that whether there is fraud happening in network or not. And if there is success, there will be no graph added. Here you can see that we have run the prediction, but there is no graph. But if there is any suspicious data that will come in our prototype through the bank systems, like it have detected anomaly. So our model will connect a graph to the user account for network intrusion that one anomaly is happening. And the second model is UPI fraud prediction model. All of our model works on 98 to 100% accuracy. Uh, so we will again run the UPI fraud detection data for detecting the fraud or the anomaly. As soon as we run prediction, we will get that it is happening fraud here. So our model will again add one more node to the graph that will show that there is a fraud of UPI, that is high risk fraud. And the third is payment fraud detection. If so let's take an example, like if I am paying someone on UPI 500 rupees, I can see that I can see that I am paying 500 rupees, but on the backend side they have changed the amount. So they will check the it will check the backend. uh, let's run the fraud data. As soon as we will run prediction, it will say that it is a fraud. So one more node will be added here. And the fourth is the credit card fraud detection system. It will detect whether a credit card number added or the anyone is doing fraud with credit card number or not. As soon as we run prediction, it will show that it's one means fraud is happening. It's with 100% confidence as we have trained the model to the best. And for now we can see that there are four dots that are connecting to it. That's what it is, what it was said in the or was asked for the problem statement, that what we have to build is the correlation graph. So this is the correlation graph. For now the bank systems have something like they can detect the credit card fraud or the other fraud, but they all remain separate from each other. So what we have thought that we thought that the one thing is common in all this fraud, that the user account is one. So we have added a user account in the center and added all the network fraud that is happening. So if all the anomalies are happening with one account at the same time or in 1 to 2 days, it means it's a fraud. So if the graph exists, it means it is a fraud. And our model is also showing that it is 96% fraud. Also what you can do is you can download the JSON data by clicking on the graph button. What this JSON data will show is will let me show you. Hmm. This is the fraud data, that what types of fraud are happening in very much detail, like what is the mapping channel name, how many times they have tried the password, and the username of the hacker or account they are using, the IP address of the phone they are using, all of the data you will get here. And it is a detailed data format, and which is of around 5000 line. So it's very secure. Also, you can check the history, like at which time, at which date the fraud has happened. Let me also open it for you. Like if the model name, it's the ML model name, but you can see what data point they have used, um, what the balance they have entered, and many more. It is also the network data, that what host they are using, is the connection private or not, what flags are they are using, what type of attack it is, and the date and time attempt, or they have succeeded or not, how much probability our model has predicted the fraud. Also, the third one is report. You can get the entire report just clicking on the report button. We have two options for checking the report. First is for JSON data. JSON data is mainly easy to analyze, so have we have given the analysis of the attack in the JSON data. But you can also do one thing. You can just print it. By printing it, you can see that. Let me show you. Hmm. It is the report. It will give you a report like this, in which the percentage of fraud is will be shown, the graph, connected graph, and the time at which fraud has happened, like the date, the time, also the type of fraud, like low, critical, high, and this is just the model's name they are showing. Fraud timeline you are getting. So this is the print button that actually works. From clear, you can clear the whole timeline and what you have researched so far. Also, like right now we are connecting it through sample data, but then when we will connect it to the bank server, or when we get selected for making the actual version, we will connect it to the bank server or the network, so we can get the data directly. Also, you can have dark mode and light mode here. Also, we have made one more algorithm for checking the quantums, or quantum thing, that what was given in the problem statement, that we have to find some solution for the quantum decryption attack that will happen in the future. So what we have thought is of a quantum score. It is a score which we will give for different anomalies that is happening for the that is happening on the internet. Like if there is a strong password which the bank has check marked that it is a strong password, and if it can be hacked in a small amount of time, like uh, for 5 to 6 seconds or something, so we will mark that it is one of the anomaly, that it can happen that the other side of that other side which is hacking the bank system is the hacker using the quantum computer or quantum technologies. So we have given different weightage to different behavior, like the transaction behavior, user behavior, device network, intelligence. They all work with different priority, and we will calculate the score. Like here, for this is the formula for calculating the quantum score. So what we will do is, we will calculate the quantum score, and we will use the interpretation matrix or graph or range to calculate how much risk is there. If like here the point is, the score is 70.5, so the risk is high. It means there is a high chance that the attack that is done is a quantum attack. So that's all. That's how our prototype works. And here is our team. I'm Kishan Omkar signing off. Thank you.